Are there any questions on this one? Uh-oh, there we go. Okay, that's awesome. Are there any questions on this? Okay, so here's one I want everyone to try. It'll take about 5 minutes. Okay, so I'm going to stop the recording. So here we go. All right, so here's another question, okay, that we're going to work on now. All right. So again, you know, we're subtracting, so we need to get a common denominator. And since we're going to be simplifying, we really want to get the LCD. Okay. Now, so here, let's do this. Okay, so we factor each one of these. X squared minus 9, you know, that's a difference of 2 squares. We factored it before, actually. It's x minus 3 times x plus 3. For this one, we get x squared minus 8x plus 15. Okay. Now, you want two numbers then whose product is 15 and whose sum is negative 8. Well, hopefully you can see that 5 and 3 would not work because their sum is 8, but you can negate both numbers. You know, by sap and sun rules, you'll still get 15. And negative 5 plus negative 3 is negative 8. I know some people have said this, that I think I remember learning in school this actually. If this is a plus over here, that tells you both numbers have to have the same sign. And if this is a minus, then they're opposite in sign. This sign over here tells you the sign of the bigger number. So here, the two numbers we're looking for both have the same sign. This tells you then that the bigger number is negative, hence they're both negative. So, you know, I hope that makes sense. I mean, if it doesn't, that's okay also. So we have x minus 5 times x minus 3. So these are the denominators factored. Okay, so what are our irreducible factors? Well, we have x minus 3, right? That's here. X plus 3, we have that here. Here, x minus 3 is already handled. We have x minus 5. Okay, so that's good. You know, the numerators you don't have to worry about for now. Okay, also notice that each factor, the only exponent is 1. Hence, the greatest exponent of each factor is 1. So the LCD is going to be this. Right? You raise each factor to its biggest exponent, which here happens to be 1. So that's what we get here. Now, here, what do we have? Okay, so now we want to rewrite each rational expression. So the denominator is the LCD. Now, we know x squared minus 9 is x minus 3 times x plus 3. Right, so we know that. What are we missing? We're missing x minus 5, right? So we have to multiply the bottom by that, but we also have to multiply the top by that. Right? You know, you have to keep everything algebraically the same. So we get this. All right, now we have this here as well, the second one. You know, we factored the denominator. We got this. And so from here, what do we get? Well, we get, oh, this should be 3x minus 5. And let me see, did I make a mistake there? Yes, I did. Instead of, okay, yeah, let me fix that. Let me just cross it out. I mean, the rest of it is right. Basically, remember, when you factor the denominator here, it's x minus 3 times x minus 5. And so you're missing x plus 3. So we put that in. But again, what you do to the bottom, you do to the top. And that's how we get this. Okay, yeah, sorry about that. This, I don't know, I guess I copied this. I fixed everything else but this part. So my mistake. Anyway, this is what we get. So now that subtract these, we subtract these. Right? As you can see. Okay. Now, when we subtract, as you can see here, right? We have to actually carry out the multiplication. We subtract the numerators, but we also carry out the multiplication. So for here, we're going to get 3x squared minus 15x. Whereas here, we get 3x squared plus 9x. What am I doing? Plus 9x minus 5x minus 15. Now this is minus, so we have to distribute the negative. That's why I use parentheses. Before I did that, actually, I did combine like terms, the 9x and minus 5x. Now we distribute the negatives, as you can see. And then, of course, we combine like terms, so the 3x squares are gone, which is nice. We have minus 15x minus 4x. That's minus 19x plus 15. And what's nice about this one is, hopefully you can see that it's simplified. I mean, the numerator is actually an irreducible factor. And it's mostly because 19 and 15 have no common factors, and we have x to the first here. So, all right. Are there any questions about this one? Okay. So now I'm done with this section. What I'm going to do now is move on to chapter 8, but we're not going to do all of chapter 8. What I'm going to do is, just a little bit of it. Mostly what I'm going to deal with now is systems of equations. Let me just get the notes. Here we go. Right? Wait a minute. What happened? Oh, save that. Yeah, save it. Okay, let me share it now. Here we go. Okay. Okay, so here what we have is a system of equations. That's what we deal with in chapter 8. I mean, chapter 8 goes a lot more into this stuff, but I'm only going to do a little bit of it. Basically, in this chapter, what we're going to focus on is a system of linear equations. So first, of course, we're going to define what do we mean by a system of equations, right? We're going to say what that is. And we're going to show 3 ways to solve a system of equations, a system of linear equations. We're going to see the method of substitution. We're going to see graphically, and we're going to see elimination. They're all like very nice methods, okay? So let's see. So this is what we're going to see in chapter 8. So in a sense, as you'll see, we're going to kick it up a notch. In chapter 1, we looked at one equation in 2 variables. Here, essentially, we're going to look at 2 equations in 2 variables. And this is some vocabulary. Any collection of equations in the same variables, okay, is called a system of equations. So you have a collection of equations, all right, and they have to be in the same variable. So they have to be both in x and y or whatever variables. But again, what we're going to deal with is this, systems of 2 linear equations in 2 variables. That's going to look like this. Okay. And here, the a, b, c, d, j, k, those are constants with the conditions that a and b are not both 0 and d and j are not both 0. If they were both 0 in either case, you really would just have one equation and 2 unknowns. And we'd be back in chapter 1. Okay. That's what a system of two equations in two variables, two linear equations, excuse me, in two variables looks like. Now, okay. Now we want to know, okay, so we want to deal with these. In particular, we want to solve them. Well, what does it mean to solve them? It means to find a solution. And what is a solution? That's here. A solution to a system of two equations, in two variables, okay? It's an ordered pair of numbers that's a solution to each equation. So you're not just looking for ordered pairs that satisfy one equation, you're looking for ordered pairs that satisfy both equations. That's what we're looking for. That's what a solution is. So a solution to a system of equations in two variables, x and y, it's an ordered pair of numbers that is a solution to both equations.